All right, I think all of us made it in except for Austin this morning.
Yeah.
Okay. So I'm going to go ahead and be recording for Austin and anyone who's gone in period 6. For those of you guys just joining us, we have been grading the evens. I'm going to scroll quickly, pause, because we already started checking. I think those of you guys in class were on number 28. Have we checked that one yet?
I don't know.
Okay, that's number 28. Final answer, 2x squared plus cotangent plus c, which should have worked perfectly when you derived backwards to check.
Wait, you were checking 2?
18 was...
There he is. His final one would be, you could write it two ways, negative 1 over 2x to the 6 plus c, or negative 1/2 x to the negative 6 plus c. You see it? With negatives, just remember you're adding one, so the power is going to get, in a sense, smaller, which is a little weird. But yeah, you could have rewritten it as, you could have kept it this way and maybe rewrote it that way. Number 26 and 28, we're good on? And then we only have one more. Before I turn to number 44, before I scroll down to number 44, kiddos, what made that one harder?
44?
Yeah.
Well, it was...
What did it give you?
What gives you...
The second derivative, and it wanted you to go all the way back to the original, which means you had to integrate once to get to the first derivative and integrate again to get to the
second.
But they also wanted you to find the arbitrary constants, the constant of integrations. So you had to use clues, and I think they gave you two different ones. One clue was for when you made it back to the first derivative to solve for that c, and the other clue was when you got to the original to solve for that c. So you're going to see like a C1 and a C2 because there are two different plus c's. One which happened when you went to the first derivative, the first integration. And you're going to see another plus c when you went to the original. Was it helpful, do you think, to have fewer problems and really focus on understanding these ones? Did it make it so that you tried 44 maybe longer than you would have with a longer homework? That would have been more discouraging?
For sure.
I was just checking. Not that I can always make them super short. Not super short, but shorter. This one was shorter, I think you guys felt. But I really wanted you to think through 44 and not be discouraged by the time you got there and just stop. So this is what you were given. The second derivative, a first derivative clue, a point of a first derivative, and a point of the originals. So you'll see the first integral they did, they called it f prime because you were going back one step. You were anti-deriving, going back one derivative. So the very first antiderivative would have been 2x to the negative 1 over negative 1, or negative 2 over x plus c. They named it c1 because they're going to have another one in a second. That's okay. They could have named that one c and this one d. I don't know. But then they used that clue of, hey, let the y or let the derivative equal 4 when x equals 1. So they plugged in. 4 was the f prime, 1 was the x. That's how they got c1 is equal to 6. So they were able to say, hey, now I know f prime. It's negative 2 over x plus 6. And then, oh, I need to take another integral. So they plopped that one into another integral. So that we can antiderive and go back another step. Some of you guys might have gotten caught at the power rule. Remember, negative 2 comes out as part of the answer. 1 over x is not power rule. 1 over x goes to ln. There is your next arbitrary constant to solve. So
for that part where it's like negative 2x plus 6,
yeah.
could you have done the hard thing, or would that not work? Because it's not like, yeah, like the fraction part.
Well, the problem with the fraction part is there aren't two pieces in the fraction to like cut it up. Does that make sense?
Okay.
The plus 6 is separate. You could have put them together if you wanted. But if you put them together, it would have looked like, let's see, we've got like a little common denominator. You could have done that. And that would have been negative 2 plus 6x over x. So you could have put them together to make a heart. But the heart method is only used when it's all put together and we want to split it apart. So this one was already split apart.
Oh,
Does that kind of make sense?
yeah.
And the reason why, in this problem specifically, we wouldn't have wanted to put them together with a common denominator is because in the next step with the integral, we wouldn't have been able to integrate until it was written all separately. So we like it like this, so we can take the integral of that piece and that piece separately, just easier.
Makes sense.
How many of you guys got stuck on 44?
I just didn't know, but
Okay.
I
You just did it wrong.
forgot to have it, put
Okay.
the 6 in.
Did you see though that you had to go back twice, you had to anti-direct twice? Okay. And that's why they had to give you 2 clues. One clue was for the first derivative step to get that plus C. Second clue was for the original step, or to get back to the original, which is that plus C. So that's your final answer. Does anybody know how an AP person writing a question could have rewritten this answer in a little bit nicer way?
Could you take it out common denominator, or common?
Almost, except 263, there's nothing in common.
Could you take out the negative?
You could have pulled out a negative. You could have pulled out a negative, and that would have been negative, and then positive, negative, positive. But I see something else.
Can you put something else?
Yeah. ln, power property. I could throw this up here.
Oh.
And it could be, let's see if this makes sense, ln of no absolute value, 1 over x squared, plus 6x minus 3.
I mean,
Why is one over here?
Oh, okay.
like,
Because you could pull up the negative 2. And x to the negative 2 is 1 over x squared. And 1 over x squared
All values
doesn't
are
need
positive.
absolute value because
always
it's
positive.
always positive.
Would it
1
be-
is positive, squared is
Would
positive.
it be wrong to put absolute value, even though it is always
No.
positive?
But what I was thinking is if this was a
It's
multiple
worthless.
choice, would you match it with this guy? That's what I was thinking.
yeah.
So this
well,
is
you,
right.
you would probably, because you see that this plus 6x minus 3 is right,
Yeah.
and odds are,
Just hopefully there's not an
Well,
answer that
yeah.
has like a positive 2 ln absolute value x. They wouldn't write this
Yeah.
exact thing, because this is right. But if they changed one little sign and you didn't have full confidence in your answer, you might go for the one that's incorrect.
well, that's why usually you check both of the answers if you don't know what's right.
Yeah. All right, kiddos, that's the end of homework, I think, as far as evens. Were there any odds? I mean, you guys could figure out the answers to the odds, but any odds that we were stuck on?
49.
49 we didn't like?
It was like
Interesting.
I loved it. It was so much fun.
Is it?
Sean loved it.
Should
Sean,
I-
what do you remember about number 49 since we're talking about it?
Okay,
tree growth.
so it's about tree growth, so they give you a rate, and
Ooh,
then,
and the rate, hold on, when we hear the word rate, what should we think? Derivative, okay, so they give you a
so they
rate and
give us the
formula.
rate formula.
Okay,
And so it's telling us about, it's talking about seedlings, and when they start, when time is 0, the seedlings are already starting at 12. So we have to work back to the original function to where we can get height from time, because we have this rate, but we want just a direct relation. And then, using that formula, that new formula that we have, the original, we can plug in a certain time and get out a certain height.
But, oh wait, did you find seek?
Yes,
Okay.
so when you integrate
this is the clue that you're
that,
talking about.
Is
right?
it 0, is it 0 and 12?
it's at 0, 12. So, because when time is 0, the height is going to be 12. So when you plug into your function, your constant, in the end, when you do the math out, it's 0 plus c equals 12.
Okay.
So your constant
Yep.
is 12.
And then what do you do after that?
So after that, you have this time that you're given, 6, t equals 6. And you're like, oh, plug it in and see what height I get.
Oh, that makes it easy. For some reason it didn't.
1.5 would be 3 halves, right?
Yes.
So much easier.
No,
Yeah.
1.5 is nice.
Well, but do you want to do 1.5 divided by 2 is 0.75? I mean, if you like that, I don't like that though. Divided by 2 because we have a t squared, right? And then we need to divide by 2, which would be 3/4. I like that better, but to each their own. and Nathan and Sean were both talking about needing to find plus C, and they have the clue right here because 12 centimeters high, that's the height, that's H, and T is 0. So then Sean, when you did plug in, because this was equal to H, what'd you solve for C? What did it end up equaling?
12.
Okay.
Which makes sense because, like, when you're like, when you have a function and you're like the vertical shift or something like that, it would be starting at that height of 12. All seedlings would be.
Yeah.
So like on a graph, it
For
would
a
make sense.
polynomial.
For a polynomial, yeah.
Good. So then we know C is equal to 12. And so that was the answer for letter A, right?
Yeah.
Just H of T is equal to my function.
Mhm.
And then what was the question? I heard you guys talking about it, so I think they're talking about the 6. What was going on with letter B?
They wanted you to find
The height. So since now we have the function of height to time, we can take the time, which is 6, and get our height.
Good. So once you have the function, it's easy cheesy. They just want a particular one, so then plug in the 6 and
What
solve.
was it? What was it equal to?
69 centimeters?
69.
They said they sell them when they're 6, after 6 unit growth. That's why a Christmas tree farm can definitely be a little scary because you are always planning for way down the line when you're planting, when you're buying, and hoping you bring in enough profit to make it worth it. And people don't start buying fake trees. Okay, 49. Nathan, we're good? Anything else? All right, cool. I'm gonna have you guys actually keep open your homework files. I'm gonna walk around really quickly and see that you have it attempted. I'm not saying I'll do a homework check on every homework, but I'll do it on quite a few. Because we realized last semester some of us need more accountability. But as I come walking around, I want you guys in your notes, as a group, before we start our integration competition, to play with the following, which is similar to number 49, just in the way that there are words. In the way that there are words. Let me come around and look at your homework really quickly.
Go with words.
I think technically this is example number 9. I'm having you go in your notes, that way you don't have to go, normally I would say back of your spiral. Not in your section, we're getting to that soon, but. Number 9.
Oh, I have one way. Wait.
See what you guys can do.
X1 no y-axis. So it's like x, y. The distance is x.
The directions, kind of like from homework, would be solve
So m,
the differential equation.
m is equal to x.
I would say dy dx.
Yeah. X squared.
You could say m, however, you need to know that m is slope of the tangent line, you need to know that's the derivative.
Oh, it's slope of the tangent line? So it's.
Because it's all the slopes.
Oh, wait, it's the y-axis?
You can think the rate.
So it's x.
All the slopes.
So instead of m, you should do
dy dx, or f prime of x. So it's not talking about one
Oh.
slope, it's talking about all the
Oh, yeah,
slopes.
use,
Hence why you have to use the derivative function.
wait, and then use so it's not terrible. Point that in here. Is it x squared?
So,
Well, yeah, and then you
Yeah,
just square
and
the
then-
distance.
Well, the distance-
where it?
Well, but you don't need the distance point because it's just a point in the y-axis.
Yeah,
so
exactly.
It's just x.
The distance between a point and the y-axis is the horizontal, which is just x squared.
Okay, not just
So
x.
dy dx equals x squared. Very weird way of putting it.
And then you derive the. Whoa.
And so how do you go backwards, guys, from the derivative, dy dx?
The integrate, so you integrate x squared?
Yep, rho x squared in an integral, you have an x and a y that will help you find c. Did 49 help you there, Julie?
Oh,
I think so, huh?
yeah.
No, not 49 help.
Yeah. It's just missing B.
But yeah, I'll count it. Just next time, remember, write the question down, then maybe I can give you a quick.
Plus,
And then you see the full name
Okay, you're in there. That's right, so, some of the steps.
Very easy.
yeah. 2, 1, 3. So when I'm doing 2 is 6 over 3. Alright. So then you add 7.
Okay, so
Wait, Dirk, what'd you do?
so
I'll stand up and walk over. The better way is that we clean. Do we win anything?
No.
Chip can?
Oh, you mean the integration competition?
Oh, yeah.
I used up all my stocking stuff on.
What about like a promise?
Dark almond is good.
She got wrong, I always throw that people.
Get what, ramen?
Alright, so.
This is number 25, right? Yeah, homework.
Okay, 2 plus 1.
And then Austin, I just need to get his checked, the rest of you guys checked out.
Uh,
Okay, good job getting that homework attempted, kiddos. Let's go ahead and talk about this one. So dydx equals x squared, and they gave us the point, or the clue, -1, 2, of the original curve. So hopefully you guys threw the x squared into an integral. And if you didn't understand what was going on here, slope, the slope of the curve, that's not just one number, that's all the slope, which is why we made it the derivative. The square of the distance, if you take any point on a curve, how far away it is from the y-axis is always the same thing as its x value. So that's what was going on there. So any point, if you were to figure out how far from the y-axis, would always be its x value. So that's what was going on with our picking the x squared. When you guys integrated, you should have gotten 1/3 x cubed plus c. Then you would have plugged in our clue to say y is 2 when x is -1. What'd you guys end up getting for c when you simplified?
7/3.
Because it'd be 2 plus 1/3, right? 6/3 plus 1/3 is 7/3. And then how do you write the entire function then? Y equals 1/3 x cubed plus 7. You okay? Just the wording was weird, right?
Yeah.
Okay. So then, last example before we just go for it. Number 10. Some of you have started memorizing your formulas or your properties or your
I wish.
integration rules. So question, is cotangent squared in any of those forms?
So,
No.
You can use some trick identities or something.
What trig identity could we use? This might have been helpful for one of the homework problems
I
last
don't
night.
know, I mean,
Well,
1 over sine
oh,
squared.
The one with
equal to
tangent
s-
squared.
It's equal to no, wait, cosecant squared x plus
Is 1
Or is
over
it-
sine.
a -1, okay, there we
Now
go.
hold on, what if you didn't remember that?
Give up. Cry.
You could split cotangent squared, like you could like rewrite it as cosine squared x over sine squared x.
Pause, do you guys remember this one? Maybe easier than the Pythagorean rearranged? Okay. How could I change, wait, what's cosine squared equal to?
Plus 1 tangent.
One minus sine
Oh
squared.
boy.
And then.
I'm just showing you how we can get that, the cosecant squared minus 1 another way. If you remember cotangent squared is cosine squared over sine squared, you can change this numerator, because remember the heart method. I want to be able to have the numerator such that I can split up. So I'm splitting the numerator, because denominator, if I split him, I'm stuck. And if I split the numerator, maybe I can actually take it apart. So, part method. Here's a good application. Split it up. What's 1 over sine squared? The same thing as cosecant squared. And what's sine squared over sine squared?
Oh my god.
So if you don't want to remember the Pythagoreans, which maybe you guys might want to add your forevers in the beginning, sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. 1 plus cotangent squared is cosecant squared. You could write those down and work on them, or you could say, wait a minute, can I do that if I need it? It's up to you.
Does the AP give us trig identities?
Not trig identity problems, but could they give you an integral that you might need an identity for?
No.
Rarely, but they could.
In the beginning, how they have like given information?
Mm-mm.
No. Rest in
Sadly,
peace.
no. There's no like major formulas for calc.
Oh.
But there is like that every now and then in a problem they'll give you an area or volume formula of something other than a square or circle, but that's about it. Unless they're giving you a function, but that's it. Why is it so helpful, for those of you that aren't even quite sure why we're doing this, why was it so helpful to change cotangent squared to cosecant squared minus 1?
Because we
Their
have to look
rules,
up
good.
what
The integral of cosecant squared is
squared x.
Negative cotangent x.
negative cotangent.
And you're not allowed
Because
to use
cotangent's derivative is cosecant squared, but with a negative, it's not there, so I put it in the hand side derivative. And then, what's the integral of negative 1?
X.
Or say minus 1 minus x, but don't forget your
Let's see.
see that everything's there. That's what I did. See that everything's there. Excellent job, kiddos. Let's go ahead and close our notes, close our homework spirals, get out that. How many groups do we end up with? We have 1-ish, 2-ish,
I don't know.
3-ish, 4-ish.
Bluefish.
Enough fish.
Yeah, we have 4-ish. Do you guys want the nice firm boards instead of the really flimsy?
Yes.
All right, here you go.
Oh.
Switch. Give me the flimsy one.
Flimsy
I'll give you a nice one.
Oh dear, there goes the.
Oh, dearie me.
You think it's action this way? All right, turn so everybody can see. You guys know the name of the game?
Saw that.
We got one person doing all of those. Everybody has a turn, and then you pass. If your marker is dead, someone will run and grab a new one.
Once everybody has a turn, then.
Okay. You ready? This first one.
Are you going first?
Alright, so are we just gonna talk it through and just like...
No, Sean.
Talk it through.
Talking is for wimps.
Talk it through. Talk it through.
No.
We're not going for speed.
Oh.
Okay? We're not going for speed, but talk it through quietly, unless you want to just be giving the answers to all the other groups.
It's okay.
Sound good?
Put 2 words.
All right. You cannot submit it until you show checking it.
Oh my gosh, Miss.
Ready? Set. Go. Write the problem first. Write the problem first.
So X. So minus.
Remember, you can talk it out. You can talk it out. Only one person can have the marker, but everyone can be helping.
Just derive it. Equals d. Okay, Miss.
Did you write the check?
Miss
Okay, let me
D,
see.
can I mean, how do you like, maybe you have to do that.
Go.
I kinda like checked it weird.
All right, 7
We just need to write it down.
13's x to the 13 plus c, right? Okay, this next one. It might be a good idea to check, but I'm not going to make you write the check. You can grab a couple markers just in case those out for you.
Wait, you don't actually have to write the check.
You don't have to write the check, but I would still advise, because you only get one submission. You only get one submission.
Spicy.
Final answer.
Die.
7/13 x to the 13 plus c.
Wait,
So far,
isn't it
all 4
trivial?
groups are tied with 1 point. Here we go. Number next one, you don't have to write the
Maybe
check,
keeping track.
but one submission. Any marks get set?
Alright, so.
No. No, too close.
Cosecant conjugation, so, yeah, right, so cosecant would be 5 sides. Negative.
And homework, so keep the notes open. There's homework.
It's negative. Is it negative? Negative? Alright, if it's not negative cosecant, you can blame me. Hey Misty, is it negative cosecant? It is negative.
Good question.
Dang it!
Yeah, positive. So, negative. Alright, if it's not negative cosecant, then Misty will tell us as soon as we get it wrong. Yeah, I guess. Okay, but it is negative cosecant. I'm just
All groups, got the second point. Final answer, and you guys were careful with the signs, right? -5 cosine of x minus, because it was a plus, needed to be a negative, cosecant of x, and all of you remembered plus c.
Yay! That's that plus.
Has anybody's group helped them out yet, or has your group helped get the right answer?
Yeah.
Okay. Just think, if you were by yourself, you might have messed up on the signs, and/or the c's, and/or the formulas.
Whoa,
Okay, next person.
negative cosecant, man. Uh-oh, alright. Let's see. So it's just
So now, we're adding the exponents. Three over three plus 1 over 3 is.
Oh wait,
That
so
seems
stupid.
But
If you, sorry, reset.
First.
now we're ready.
First, that's what matters.
It's not right, because then you derive it.
There we go, that's what matters.
Is that right? That feels wrong.
If you break down that thing, so that's
Oh, sorry, I'll hold it regular.
to the minus 4 here.
That feels wrong.
The 7 hours will be
Yes.
there because you have the one.
That's it.
Is that?
That's it.
Oh no,
That's it.
Misty, I've done it. I
Have you
told
not
you
boxed it yet?
I told you I was. Oh no, I have to box it now.
Well, I get
There we go. I told you I was gonna do it, Misty. All the time.
Did you tell Sam you were gonna do it? She didn't know it was happening.
No, yeah, she.
And so be-
Sam, you need to remember every time.
And that's just the
Even when you're taking the tests, I'm gonna need you to tell me to do plus C.
I tried to remind you before.
Yeah, I didn't box my answer.
Alright, one more group is out. Give them another couple seconds.
Is this like nerve or something like?
Oh my god.
I wonder. I'm like,
Are you ready for this quiz today?
It's when you bring the
Oh yeah, you can write the integral sign over
Is
it.
the x?
The 3 is in.
It becomes
I'm gonna fail all
Easy,
these
yep.
tests just because I
Wait, did you
forget
start
the
with
answers.
I'm gonna go. He's just gonna let.
Just checking, you shouldn't have a marker though. Alright, you guys lose the points. Final answer. No, you're supposed to have the marker.
Feels bad.
7/3. X, no, I did it backwards.
It's 3/7.
3/7. But I think you guys had it right before you changed. 3/7, x to the 7/3.
X cubed.
Let's see.
What?
I heard they even say 1/3. You guys were on the right track. Okay, 3/7 x to the 7/3. So you weren't supposed to have the marker. It was someone else's turn. Okay, number 4. New person with the marker. Remember, you're only allowed to use words if you don't have the marker. You're only allowed to use words. Okay. Number 4. Because our groups are bigger than normal. Is the integral of 5 plus x cubed all over x.
So just take
So then I can
Okay, you're allowed to use words.
go to, so.
Only one person with the marker.
But no, don't do our method. Do, bring the negative one and then distribute.
Yeah, and then just read
cancel, make
both.
it x squared equal 1 5.
Plus x to the negative 1, just for sanity's sake. And then
Or actually,
it's not just integrate.
order.
Plus 1. Oh, actually, I lied, so it's 5 instead. No, 5.
Because I was in a hard.
And now you disintegrate.
When we
Plus.
How does your brain see it? X negative 1 or like divide?
5x to negative 1 is 5, and it'd be 5, because that's what I'm going to see, 5, and L and actually back.
Let me see it. Let me see it.
Yeah.
Yeah, I was trying to just like say like, you're like the person arguing, you're just talking about it, it's like, so like say like you have the right of it, and like you're right.
You're telling me how to do it.
Yeah, that's how I.
Boy, I'm going to forget that
You
sometime.
know, because like I'm happy to think about it.
Actually,
Yeah,
we'll
right,
do
right,
that
right.
because
It's weird, I don't know.
Misty.
It's kind of cool though. You get Alfred, be like, hey, get a pencil.
Yeah, that's what I'm doing.
That's interesting. Okay. Yeah. And QED?
Wait, hold on. Just cool. In the future,
Gotta be ready,
and not add like the plus. Actually, just on one of the multiple.
You guys have it. I'm just
choices,
starting the
plus,
steps.
And then I won't forget.
Yes.
I haven't solved it. I think you guys got it. Good. Everyone got it, that's fine. Equals 5 ln absolute value of x plus 1/3 x cubed. You had to split it up first though, right?
Yeah, you did.
Yes.
All right, last one.
Unless you're smart.
Okay, last one. Some of you guys, someone gets to repeat, but the bad group, the last person's going. That's why we've been going so much.
Two
So,
groups of two.
the last person gets to go. The integral.
Here we go, Kate.
Nice and
Let's just fix that.
Give us buckets on this one.
Buckets? Duckets.
Oh,
Yeah.
Don't do trig, it sucks.
And then
You want a trig.
3x
Give us that e to the x.
square root
I
of
can't
x
see.
Oh.
plus e to the x
Oh.
over x.
I can't see Misty.
That's my
No,
word.
no, this is good, this is good. Okay.
So.
This is good. It'd be really bad if I didn't do something.
Okay, wait.
It's kind of simple, so it's
3 plus e to the x. We got it, we got it.
This is the same.
plus and then it's 8 to the x and then x to the negative 1, so actually it's just x between 0, isn't it? So,
And look.
That's x to the
yeah,
negative.
x
It's an x.
right. So,
You can't add
what
the
we have to do
e
is
to the x.
bring down this,
Oh, 5, 3? Yeah, yeah, yeah.
3
and then,
What the heck?
times
okay.
2/5.
Maybe, okay, look. How about we do this?
Misty, this might be wrong, but
6/5.
I was
You're
first.
clocking it in?
Let it be known that I'm first.
And then 3 plus 3.
Because the x, the 3x there, the x's cancel, so it'd be 3.
I think we got it right.
Oh, well, you can. But this also works too, because they would both cancel.
Is that
Okay,
wrong?
so it must be like this.
It's the best.
Oh, dang.
Do it slower.
Okay.
We did
Oh,
still.
no.
And then
Yeah.
let's do this. So it's
How you guys?
x e to the 1.
We have one more submission still out.
That's where my mistake was.
So
We have one
submission.
turn.
Oh, wait.
What?
That was one submission.
Nice job, 5 for 5.
No, they haven't done it yet.
We are
You
They've already
add,
lost the point, so you guys are fine.
you add two
We have 5 and 5 and 4 and 4.
I think what got us slipped up was not bringing the 2 fifths over, not multiplying it by half. Because it becomes 6 fifths.
Yeah.
That would have something else.
That's what happened back there. He went too fast and he lost.
Misty is at 3. Did I forget? Is that
Oh,
what I
that
did?
is
Did I
part
get
of
that?
it. But your coefficient is wrong in the first one.
3 times L.
There we go.
Does he even know?
No, Patrick doesn't have
Yes.
that. Because remember in the episode where he wrote in this?
Or,
Oh, yeah. Final answer should have been 6/5
oh, 6 fifths, okay.
x to the 5 halves plus 3 e to the x plus c. Not too bad, huh? And I tried to trick you a couple
I
times.
have a question. If they give you like a copy of the C already, do you have to put that number when you finish your equation, or do you just make it
So
up?
then,
So say like C equals blah, blah, blah.
I don't know if I've ever seen one where they just say C equals. If they give you a clue, it'll be a point, you have to.
So just imply that you have to put bucks.
But then,
Yeah, by
like distributed
there
to
being an
3x
individual
lines,
with no numbers popping up.
and this is all multiplication,
That makes
and then there's that.
Alright, kiddos, once your group fully understands that last example, go ahead and erase those boards for me. Put the boards, send one person with the boards to my desk, another person with the markers and the rags to the front. Boards to my desk, markers and rags to the front. And in your notes, go ahead and turn your desk back to the front.
Oh, yeah.
Spud Patrick!
Spud Patrick.
I was like, SpongeBob, I was like, oh, it's Patrick.
We should get this right.
Hello, someone signed marker.
I was hanging out for when we were in class and he got so hyper. He got a lot of integrals.
So,
Alright.
I like it, I like it.
I have talent.
Hey kiddos, what do you see on the front screen right now?
Motion.
integration quiz.
Okay, tomorrow, beginning of class, will be a little baby integration quiz.
Whoa!
Why are we doing this?
Oh, you had, okay, pause.
I'm like,
Oscar? Or Nugget?
Yeah. We did lots of examples yesterday. I was showing you guys were doing, right? I was showing you guys were copying. Today, you guys got to talk it out with other people after you tried homework last night, right? So then tomorrow should be a good time to see whether you have it for yourself, personally. Does that make sense? Okay, all right, so it's okay, I'm spreading it out. So tomorrow, little baby integration quiz, no multiple choice, I don't think, probably just can you work it out. I'm gonna give you like 3 integrals and we'll see what you do. Sound good?
Yeah.
Okay. So we are going, section 4.1b is back to motion, but now that we've learned integration, at least the idea of integration. We're going back to motion now that we've learned integration. Now, there is a worksheet that's going to be coming, like a packet that we're going to be working on. Sadly, the office didn't quite get it copied for today. But we're going to start motion today, like the book version of motion. And then tomorrow with the packet, we'll be able to get a little bit more done. But section 4.1b, if you noticed, homework only went so far. Maybe that's another reason why it wasn't so long. But it's because the rest of homework goes back to motion. So guys, I want you to think about the forever card, and let's see what we can remember about motion.
position is S of T.
S of T, S prime, T to S prime primes.
Okay, start writing down. We have position,
Means.
and there is notation for position. We also have velocity, right? And we also have acceleration. So given, for instance, given position, which you guys said could be what of T?
It's S.
S of T, or they could name it X of T, they could name it H of T, they could name it a lot of things. Where the thing is at, H would be kind of like a height. But position, okay, we have an original function. Now, how do we get velocity from position?
Derived.
Yeah, good. V is equal to S prime, or X prime, right? How do we get acceleration from velocity? Derived again. So I could say acceleration is equal to V prime, which would be the same thing as, how would that relate to position?
S prime of T.
Yeah, the rate of change of position, or just the rate of change of velocity, is acceleration. Now, we're not going to necessarily write the others because it's on your forever card, but weren't there other clues, like if something were to hit the ground,
Position is 0.
position is 0. If it were to say something like initially or at the beginning,
T is 0.
T is 0. If we were to say something was dropped, what would initial velocity be?
Well, probably 0 unless you
There
were.
was no thrust. Well, they would have to specify if there was a thrust or if there was a throw or if there was a propulsion like from a gun. If something is just dropped, initial velocity is 0. If something is thrown, there's going to be an initial velocity. Like you guys know, baseball players, they throw at a certain speed, right? Like if it's really fast, they're, 200 miles per hour? So if you're throwing something, it'll be with some sort of propulsion, some sort of initial velocity. What if they say constant acceleration?
Then it accelerates at a constant rate.
Yeah, then A of T would equal C, right? Some sort of constant? What's an example of constant acceleration?
Gravity.
Like when you hold.
Gravity is one example, because gravity is constant. And do you guys remember those numbers? Not that you necessarily had to memorize them, but
Negative 9.8.
like if 9.8 is meters per second squared, approximately, gravity is actually a little different depending on where you are on the face of the earth, but minuscule amounts. What was it in feet per second squared?
I don't know, 32 or something?
Yeah, negative 32. Why would gravity be a negative number?
Because it's going downward.
It's a force pulling downward. So then we also have this idea of velocity can be positive or negative. If velocity is positive and you're in like a right-left model, a simple horizontal model, if velocity is positive, which direction is the object moving? To the right. If it's negative, it's moving to the left. Good. Did we talk about if velocity was positive and acceleration was positive?
Yeah, well then it's speeding up in the right direction.
Getting quicker. Then, and if velocity is negative and acceleration is negative, then.
No, then it's speeding up in the left. And
But when the signs are
it's
opposite,
decelerating.
then it's going to decelerate. Was that in a Trevor card? Speed increasing, decreasing?
I don't think
I
so,
don't think
but
so.
it's pretty obvious.
Stink. I have the worksheet right away. Let me go see. Let's go here. We'll start with book stuff. Since the office didn't get it copied off yet, it should be soon, I hope. But since we're kind of waiting on them just a little bit, let's go ahead and go to our book. And that's good, because that means we can start homework a little bit at the same time, right? We'll get to the worksheet a little bit later. So let me get this book stuff first. The speed increasing, decreasing, we'll talk about in a little more detail with the worksheet. Let me get rid of this. Don't worry, it's coming right back. Let's go right here. Okay. So let's go ahead and start here. And let's see how integration can come up. The nice thing is you guys have already seen motion to some extent. After you get the problem-solving steps, I'll go ahead and zoom in. You've already seen motion to some extent. Just we're introducing integration. And actually the packet I'm going to give you has some differentiation and some integration in it for us to consider. So identify the givens and draw a picture if possible. Identify what to find. And you guys know from related rates, from optimization, we want to mathematically model what's going on. We want to take a situation, take a scenario, think about the movement, the motion, the givens, the units, and think about how to mathematically model the situation. Can we plug into a formula? Can we state a function? Can we find a relationship? So let me zoom in on the problem so that you guys can start reading it and considering what's there. I just have lots of space in case we need it. But here's an example from 4.1b. A ball is thrown upward, thrown. There's some sort of propulsion with that. With an initial velocity, okay, that makes sense, of 64 feet per second. From an initial height of 80. Find the position function, giving the height as a function of the time t.
So,
Now, give me 1 second to say something else. Since this is not a physics class, we're not necessarily just going to be memorizing formulas. That's not really the point.
You want to integrate.
But let me say that this model, you are given a constant acceleration, which could be actually stated in the paragraph above, constant acceleration. I think you guys saw this in the motion homework before. They said, hey, consider that the acceleration is equal to gravity. So guys, are we measuring in feet or meters?
Feet, because
So it's going to be
we're
negative
close.
32 feet per second squared. Okay. How can we get to position starting from acceleration if we're not given much else? Integrate. Because acceleration is the second derivative. Hey, what homework problem last night is going to help us go from a second derivative to an original? Number 44. This is an example. You're given the acceleration, which is a second derivative. We need to go backwards to position, which is 2 steps back as far as differentiation, anti-differentiation.
Wait, why is that acceleration if it's, says it's initial velocity is 60.
Well, yeah, that's used
That's
to find your
velocity,
C.
though.
You're gonna use that to find your C, but then your acceleration is negative 32. So
The acceleration, remember,
just
is
integrating
how quickly the rate of change is changing. So velocity says how quickly the ball is moving. Acceleration defines how the velocity is changing. And if you're thinking that the ball is being thrown upward, isn't it going to eventually fall? Why? Because acceleration is acting on that velocity, making it slow down. Well, become less positive and go negative. Does that make sense? Yeah, it's a little weird. So we can right away say, hey, velocity is equal to the integral. Oh, there's another way of explaining velocity. It's not just x prime. Velocity is also the integral of acceleration. Does that make sense? If acceleration is v prime, then I need to go backwards to get to v. I need to anti-derive. So we're going to add to those formulas that we wrote down earlier in our forever card, because now we know more. Now we know we can take an acceleration like gravity in this example, and we can integrate in order to get back. And we're going to use clues like, hey, when time is 0, v is 64. Or we're going to use clues like, hey, for position, when t is 0, x is 80, to plug in for our plus c's, just like 44. Does that make sense? Alright, you guys can start playing 4.1b homework. It's not totally due tomorrow, but I would at least get a little bit into it and be like, wait, am I totally good with this, or does it get a little tricky still?
I mean, it's a rather simple concept if you know motion already.
We know the 1/2 for constant acceleration model, but the AP rarely gives you constant acceleration, so you have to not use that formula.
Because